Once again, for some reason it was not. Okay, we're back to the recording. In general, it doesn't really matter whether we're talking about a matching engine or a centralized or decentralized exchange. The difference is how it is implemented, either for a centralized case as a standalone server, or in a decentralized case, it is implemented as a smart contract, and then the blockchain itself is responsible for invocation of that smart contract. So what is important to understand today is, I would say, the general principles. First of all, how orders and trades are entered into the system, and then think about data structures and technologies, how we can implement this. So let us see. If it may very well be one of you is familiar with this stuff, perfectly okay. Others might not be. So if you need any clarification, or you think it is too slow or too fast, please let me know. So the most important thing is, let us discuss the entities to be implemented. The first entity we need to be aware of is order. Intuitively, it is quite clear what the order is, all right? So someone submits an order to the exchange in order to, it's a tautology, in order to buy or sell a particular instrument. Well, even before orders, as we have already discussed, we discussed this last time, I think the first zeros entity we need to talk about is the instrument, right? From our discussion last week, do you remember what the instrument is? A tradable instrument.
Tokens?
A pair of tokens. That's a very important thing. So the instrument is actually a token or currency, call it either way. Token A, token B. And usually in text notation, it is denoted as token A over token B. That's a slash. Or simply as AB. I mean, if, for example, token A is our Inno Sport Center token, SCT, right? And token B is Ethereum, then our instrument will really be Inno SCT over Ethereum. Then the designation of our instruments. Usually, if there is one less liquid coin and there is a more liquid coin, obviously, you know, in SCT is probably less liquid as yet compared to Ethereum.
Excuse me. How would you explain this notation?
Oh,
My idea here is that Usually, if the second one is more liquid, like USD, in comparison of a ruble, the usual behavior of the graph will be
opposite, usually.
will be growing. So more liquid assets are usually less inflated, maybe in this case.
You are right to some extent. It is a matter of convention, and let us explain actually why in our particular case we probably favor this convention. Let's see. If this convention is not good for us, then we can do it the opposite way. But why I may think it is a good idea. So and compare to, for example, USD ruble. Indeed. So let's see. First of all, suppose for the moment that we have adopted this convention. Then we'll see if it is just a good thing to do it the opposite way. Might be. Suppose that it is this way. In general, when we have A to B notation, then what is important is that how we define the price of the instrument. The price is typically denoted by px. Px is from the French prix, of AB. So what is the price of the instrument AB? This is the number of B units equivalent to one A unit. So for example, exactly same story for USD ruble. Price of USD ruble, where a ruble is B and USD is A, simply because it comes first in a pair, in this pair. Then price of USD ruble is the number of rubles equivalent in value to 1 USD. So when we say, for example, price of USD ruble equals to 75, it means that 75 rubles are equivalent in value to 1 USD, which is what we expect in this case. So that's very important, that the price of A to B pair is always expressed in the number of B units. That's just the convention. So for this reason, making the pair in an opposite way, Ethereum to InnoSCT, is probably a bad idea, because originally our InnoSCT has absolutely no value. Before we start charging, of course. Originally, intrinsic value of InnoSCT equals to 0. Therefore, if we quote the price this way of InnoSCT to Ethereum, then it would be what? It would be number of Ethereums equal to 1 inner city, because inner city is worthless at the moment, then this price would be 0. On the contrary, obviously the price of the inverse pair, Ethereum to inner city, is 1 over price of inner city to Ethereum, and for that reason is equal to infinity. We don't want infinite values, and for that reason it is convenient precisely to have liquid, or at least, by liquid I mean having some intrinsic value, currency or token, as the B token. For that reason, that's why. What is inconvenient in this case, slightly inconvenient, in the future, we expect price of inner SCT to Ethereum being positive, so not 0, but small. This is contrary to convention, because, for example, typically, and you can see it from USD ruble point of view, is that not only we want obviously this price to be finite, so it is not infinity, but we also want this price to be normally greater than 1, like USD ruble, for example, USD to Canadian dollar, USD to Japanese yen, this euro, or other way around, euro to USD. So we would typically want this price to be greater than 1. In our case, it wouldn't happen. So unfortunately, we would say the desired property, the desirable property price of in SCT to Ethereum, which is again a convention, that's why it is a desirable property, price A to B being greater than 1, does not hold. So you see, if we do it this way, our choice is, I would say, conflicting anyway. If we choose it as in CT to Ethereum, then we do have finite prices always. So it could be 0, but it would not be infinity. So it is finite. But if it is not 0, then it is a small value, and the condition, desirable condition, that is greater than 1, doesn't hold. If, on the contrary, we select it other way around, Ethereum to inner city, then it would be greater than 1, and it would be very large values, I presume, but it could also become infinity, and it would be infinity to begin with. So whatever we do, either way, we cannot satisfy both desirable properties, that the price is finite and the price is greater than 1. Unfortunately, it doesn't work. For USD ruble, it does work, because ruble is at least has some non-zero value, maybe small compared to USD, and that's why USD ruble exchange rate, it used to be 75, but still non-zero. So it is not a junk paper, definitely not. So for that reason, we can simultaneously satisfy both properties, that the price is finite and the price is greater than 1. For our INCT coin, we can't. So choosing between, I would say, the smallest, selecting the smallest evil, okay, small values are unfortunate, but okay. Whereas having to represent infinite exchange rates is a very, 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 very bad idea for our design. So I definitely don't want this. And because I don't want infinite prices to occur, then I select this way. So InnoCT is A and Ethereum is B in this case. I hope it should be clear now why we do it this way. Another problem occurs if we have two coins. If we have two coins with zero value initially, so that's a problem, obviously. In that case, we have a value 0 to 0. Obviously, it is a problem. Um, we need to think about what to do in that case. Maybe initially we will introduce exchange rates of our new coins to Ethereum, and only when, let's say, some non-zero value occurs, we'll do values relative to each other. So, at the moment, if we have, what was the name of our second coin? One of them was in the SCT, and what was another one? Price of in SCT to some in coin 2 is undefined. Both have zero value. So postpone that. Do it later. So for the moment, initially, we'll consider instruments which are in the coin N over Ethereum. This allows us to do at least something. Okay, so as we say, any instrument is a pair of two assets, but these are not the only characteristics of the instruments. So apart from that, there are other properties of instruments. So let's discuss which, apart from being a pair. What do you think? What else? Okay, we have an instrument which is in the city of Ethereum. So what do you think are the properties we need to make a decision about which characterize our instrument, apart from just its composition? we already know it's a pair of assets. We designated what is A and what is B. What else? In exchange trading, there are some, again, it is a convention, but there are very typically the following two parameters used. So first of all, when we build an exchange, then usually, especially for centralized exchanges, prices are not arbitrary. There are multiples of a fixed price step. Okay, multiples of a price step. The question is whether we want anything like that. That there are multiples of a price step. For example, if we go back to this fiat currency exchange example, USD ruble, then again, in which units the price step is expressed. As the prices are expressed in the units of currency B, USD ruble price is expressed in rubles, right? In rubles, in the B units. In CT to Ethereum price is expressed in Ethereum. So what is the smallest fraction of Ethereum? Do you remember? For Bitcoin, it is called Satoshi, and it is 10 to minus 8
Way.
for Bitcoin. Way. Right, you are right. And it is 10 to minus 8 as well. Yes, so it is way. What we can do, we can, for example, express price of our coin to Ethereum. Always, we don't know actually what the value is going to be, but we can express it as an integral number, as a whole number of ways. Because it is not possible to make the price differential smaller. And in general, it might be a good idea, at least to begin with. For USD ruble, price step, price is fractional, and price step for USD ruble equals to 0.0025 rubles, which means 0.25 kopecks, which is 1/4, 1/4 over kopek. Not a ruble. A relatively small price step. So here, let us decide that our price step, the decision is up to you. We'll see. Price step is either one way or n way. So you you would be able to specify the value of n. What is one way in rubles or kopecks? Let's say currently one Ethereum is approximately, very approximately of course, How much in USD?
2,000.
Let's say in excess of 1,000, definitely. We don't know its value at the time when we complete the project, but let's say it is 10 to minus 3, okay, 1.5 to be 10 to minus 3 USD. 1.5 10 to 3 multiplying by rubles, for example, by 75 rubles. Excuse me, what I will do 1.5 times 75. I would say it is exactly 100. Okay, so it is 10 to 5 rubles. That's one Ethereum, roughly. Okay, 100,000 rubles. That's one Ethereum. Therefore, one way being 10 to minus 8 Ethereum is 10 to minus 3 ruble. This is probably too fine granularity. We probably don't need in our exchange the prices which are down to 10 to minus 3 rubles, although for USD ruble that's precisely the case. So for USD ruble the price step is 0.025. In our case, one way would be 0.01.
Excuse me.
Yes?
I believe one way is 10 in the power of 18, not 8.
Sorry, 18? Oh, yes.
Yes.
Yes, apologies, of course, yes, it's my fault. And in that case, you see, it is, you're right, thank you. It is not 10 to minus 3, but 10 to minus 13, and it is definitely too fine, so it's not 1,000. It is really too fine. What would we like to do? We would probably like to do, what do you think? I propose that the price step would be 1 ruble. What do you think? For testing our contracts, it would be perfectly okay if we, let's say, approximately equal to 1 ruble, obviously. And 1 ruble is obviously 10 to minus 5 of Ethereum. And that would be if 1 Ethereum is 10 to 18 way, that's going to be 10 to 13 way. Maybe if you don't like 13, use 12. So then it is 1/10 of a ruble. So that's that the price step which I would recommend. So you can express this price step either as a fraction of Ethereum, or you can express it in way. It is just an implementation convention because after all Ethereum amounts are represented as integral units of way, then probably it is a good idea to have the price step as expressed in way as well. This is your design decision. I'm just giving you an idea. One of the design decisions. Or alternatively, what you can do, you can avoid specifying any price step at all. And in that case, you would still have the minimum price step being equal to one way, because it needs to be obviously a whole number of way anyway. It is simply not possible to do an Ethereum transaction with a quantity less than one way. There are some differences between these two cases of how it would be implemented. Again, it is a design decision. I will, when I explain the order book structure, we'll get a little bit more close to understanding of how it is to be done. Or, if no explicit price step is given, it would be one way by default. Okay. So that the property for a price step. Another property is the minimum number of contracts which can be traded. So what do you think? Does it make any sense, for example, to be able to trade a fractional number of tokens in SCT, for example? Would it only be traded in quantities of 1, 2, and other integral quantities, or it is called lot? So lot, which is minimum quantity of this time A coins traded. For the moment, I suggest that we select simply lot equals to 1 for now. In general, it could be both actually greater than 1 and sometimes less than 1, but that's less frequent. So for example, if you trade USD ruble at Moscow exchange, then you cannot buy 1 USD at the exchange. What you would have to do is to specify the minimum lot, the minimum quantity of USDs to be sold or purchased at 1000. So they come in multiples of 1000. In other FX exchanges in the world, there are even larger requirements. So, for example, in most of international ECNs, electronic communication networks, performing FX transactions, the minimum lot for typical USD to X currencies would be 50,000 USDs, and even that is considered to be a relatively small lot. But in our case, let's allow the lot to be equal to 1. I don't think it makes any sense to allow buying or selling a fractional number of our coins. And when we say, it is very important, quantity of the instrument, so quantity of the instrument, QTY is quantity of the instrument AB, it is measured in the units of A. It is the quantity of A, and it is equivalent, obviously, to quantity of A times price, whatever the price is, of B units. All right. So if we have the quantity for our instrument equal to N, then it means that we are buying or selling N units of A. And this means that if we buy N units of A, then we give away price times N units of B. If we, as we discussed in the last lecture, remember, If we are selling n units of A, then we are receiving price times n units of B. Okay, so that's about our, what are we discussing? Entity number 0, we are discussing instruments. But then we want to discuss order. So for the orders, we mentioned them, and we immediately realized that we need to start with instruments. As you see, for instruments, it's quite a lot to be said. For the orders, see below. For the instruments, this is all about instruments. Okay. So about instruments, is everything clear? An immediate design decision for us. When we
Yes.
define this, yes? All is fine?
Yeah.
Then let us think about the following. So if we define multiple instruments, then would it be just one smart contract which be the DEX for all instruments, or it will be a separate DEX for each instrument? One DEX is in CT to Ethereum, another one is Innocoin to over Ethereum, the third one is the exchange between InCT and Innocoin 2, and so on. Again, it is a design decision. I would, for the moment, propose one smart contract per instrument. It is just simpler to do. DEX is a smart contract. Alternatively, you can think of it in the following way, that DEX is the exchange, our decentralized exchange as a whole, but DEX consists of multiple matching engines. What is a matching engine, we'll see shortly. So basically, it is a software tool which allows us to place orders and to do trades. And then multiple matching, one match engine per instrument. So again, it is a design to architectures. Two architectures are possible. So one architecture is one DEX, and within this DEX, we have matching engine 1, and so on, matching engine M, if you remember, where M, you remember from our previous lecture, is n times n plus 1 times n over 2. N is the number of instruments. So for example, and here matching engine 1 is for instrument 1, and so on. Matching engine M is for instrument M. That's case A. And case B would be separate smart contracts, each one for a particular instrument. So we have DEX1 and so on. dex M. And in the main part, maybe not the only part, but the main part of our dex, there is a matching engine for a particular instrument. So here is the matching engine for instrument 1. Here, there is a matching engine for instrument M. From the flexibility point of view, suppose that we introduced yet another coin. And if we introduce yet another coin, then basically our original smart contract needs to be replaced. Whereas if we in the architecture A, in architecture B, if we introduce yet another coin and we need more matching engines to trade that coin, then it is very simple. We simply deploy extra smart contracts. So for flexibility, initially at least, I would probably recommend architecture B. In this case, we have multiple smart contracts. For example, called Innodex, from 1 to M. So here we have multiple smart contracts. I would prefer this way, initially at least, while we are learning how to do it. It is better for flexibility. Okay, so that's the story. Again, what are your views? Maybe you have strong views towards architecture A. Please tell me. No, if not, then let's settle where we're going to use architecture B. Fine. So now we really need to discuss what are orders and what is the matching engine. So let's move down and we will discuss that. So first of all, that was entity 0 for the instrument. Entity 1 is for orders. What is the order? The order is a tuple. First of all, what do we specify in the order? We specify what kind of instrument we would like to buy or sell. So first of all, it is instrument. Obviously, orders are, we'll see how to model orders in our case. In general, if we have separate smart contracts for different instruments, then it is not even necessary to specify instrument in the order, because if you forward an order to a particular matching engine, to a particular smart contract, then basically an order would mean invocation of the corresponding method, and you already know what kind of instrument you are dealing with. But in general, an order does contain, when it's submitted in exchange, which may trade multiple instruments, the order obviously consists of multiple fields, and the first of them is the instrument name. Okay. Most importantly, what then? What do you think comes next in the order? Next in the order comes, you know what? You either buy this instrument or you sell this instrument. Okay? So then there is a buy-sell flag. It can be simply a Boolean, where, for example, buy is 1 and sell is 0, or it could be a character BS or whatever. So it is your choice how to represent this, but the direction of the order really needs to be specified, what we are going to do, to buy this instrument or to sell this instrument. Again, buying the instrument is actually buying asset A, and selling, that's just for you to remember, buy AB means buy A, sell B. Say sell B means pay with B, but if actually you give B away, and that's why actually you're selling B. Obviously, other way around, selling AB means sell A, buy B. Pay with B. And here receive B. Okay. What else? Buy sell flag. What else comes in the order? Quantity. Order quantity, if you remember, is quantity A. Then the situation becomes interesting. Usually, when you make an order, you specify the price, but not always. Sometimes the price may be empty, and the situations where the price is empty, uh, we will discuss now. Typically, the price will be in, so we will say price or empty. It may have some extra flags, such as order type, time in force, something like that. Maybe these optional flags we will discuss. A useful optional flag is the one which is called time in force. For how long this order is going to be active. For example, and that's not all, because prior to all this, I think it is very important to say that all orders would have some kind of unique ID. So suppose that it is a 64-bit number, ever increasing and increasing. All orders are different from each other. I introduce the terminology, and what it actually means you will see shortly, that either price is greater than 0, obviously, you buy or sell for some kind of positive price, and then it is called a limit order.
Is it restricted to be positive?
Typically, in quantitative finance, yes. It is a very important property that if you have what is called tradable asset or tradable instrument, then it is tradable by definition that the prices are positive. So they are not zero, and they are not, let alone not negative. So yes. So
there is no possibility, like with the crude oil, that the price will be negative.
Strictly speaking, it was not
In especially in the derivatives market.
Yes, you know, even in the derivatives market, for standard derivatives such as futures, the price must not be negative. What occurred, it is a very remarkable example, of course, you know, with the negative price, but really what occurred in that case, it was not the price which was negative. It was with a given positive price, the value for the buyer, if they buy at that positive price, the value of, let's say, 1 barrel of oil to be purchased still at a positive price, including the costs of storage and transformation, which are to be in that case borne by the buyer, resulted in a negative value. That's what actually was meant in that case. But in general, we should stop trading and suspend our system if for whatever reason it happened that the prices are going to zero. Let us really say that we are restricted to having positive prices. And if the price is positive, we for the moment say that it is a limit order. Maybe some other order types will be introduced later on, but for the moment we are saying that positive price means limit order. And empty price, because the price is expressed in way, then empty price, let's say it is encoded as 0. But it doesn't mean 0. It is only encoded as 0. It means market order. For the moment, what the limit order and market order is remains undefined, but we will see it shortly. This is to be defined shortly. Let's just say that if the price exists, it is positive, and then it is expressed in way. If and it should be a multiple of the price step. Depends. If your price step is one way, then okay, the price could be arbitrary. But if your price step is 10 to 12 or 20 or 10 to 30 way, then it must be a multiple of that. Okay. Multiple of price step. Good. So what happens with the orders? Internally, there is a structure which is called matching engine. I first introduce it graphically, and then we must think about what kind of data structures available in our smart contracts programming languages we can use in order to represent this data structure. So now really matching engine. So what is the matching engine? The matching engine has two sides. One side is called asks, and the other side is called bids. At the ask side, we have orders to buy, to sell. At the bid side, we have orders to buy. Initially, when we just start our exchange, both ask side and bid side, they have to be modeled and represented as some kind of maps. But what are the keys and values of those maps, we'll see. We'll see with you shortly. Both sides are initially empty. Then initially empty. You see, these are some maps. I didn't even specify yet what kind of maps, but initially they're empty. In fact, both side is a map from price to a list of orders by square bracket I denote a list, curly braces denote a map. Price to order, where buy sell in those orders is precisely sell. So at the ask side there are sell orders, and price equals to the price key. So basically what we do, we group together all orders with a direction sell and a given price and make a list of them. Simply that. When an order with another price arrives, we install another key in the map and create a singleton list, and so on. That's why graphically we can say that there are so-called price levels. So for the sake of the argument, let's say it is I don't know which unit we are using, but let's say the price of our SCT to Ethereum is of the order, let's say, optimistically saying 0.01. Then here, for example, there would be the price level 0.01. The next price level would be 0.0011. The next one is 0.0012. In this case, obviously, the price step is 10 to minus 3 Ethereum. I put it in Ethereum, but you will convert it into Wave. Just for convention, I write it as Ethereum. Otherwise, I would have to put 10 to 12 or something like that, which I don't want. And at each price level, there are multiple orders. So there is order 1 for a particular, with a particular ID. It has an ID. It is this instrument, so matching engine is specific for each instrument. obviously. Another instrument, as we already have seen above, would be a different matching engine. And here there is an order with a given ID, cell direction, some quantity, for example 5, and this price. Then there would be another order with another ID for quantity 6, then another order for quantity 1, and so on. This list for a given price and a given side, this is called side by itself. For a given price and a given side, the orders are in the order of arrival. And similarly, what are bids? It is again a map, a very similar one, price key to order, but now these are buy orders. And you see that sell orders, it is a map. We have the smallest key, which is 0.01 in this case, and other keys are larger. Graphically, we put it in such a way that there is a so-called best ask price, which is the smallest price at which our coin is being offered for sale. So if you see different owners, they would like to sell the coins, and this is the cheapest price at which someone is willing to sell it. So they submitted an order. An order was put into the order book, into the, this is also called order book. Matching engine is order book plus the mechanism of updating the order book. And then the order book. Order book is the main part of the matching engine. It is the data structure which we are currently discussing. So it contains two sides, bids and tasks. Each of them is a map from a price level to orders, respectively sell or buy, with any IDs, any quantities, but a given price and a given side. Whereas in our graphical depiction, we would say that bid prices, so orders to buy, they're lower than the corresponding ask prices. So basically, initially, suppose that the picture is like this. So here we have 0.0 instead of, obviously, instead of 1, we would have 9, 0.008, and so on. So in a stationary situation, I mean, what I have depicted here is a static order book in which nothing happens. Clients of our exchange, and here there are again multiple buy orders. So with different quantities, for example, 10, 2, 3, and so on. Clients of our exchange submit orders. What does it mean, submit orders? They invoke the corresponding method, so they do transactions, corresponding transactions with our smart contract by submitting orders. And those orders currently, let's make such an assumption, are such that the cheapest sell price or ask price is higher than the highest buy price. So for example, yes, there are people which are selling our coin, but the lowest sell price is 0.01. Yes, there are people who would like to buy our coin, but they do not agree to buy at 0.01. They say, no, it's far too expensive. The maximum I can I can give for our coin is 0.009, or the corresponding amount in weight. I'm, for example, using Ethereum here instead of weight, but you would really need to specify it in weight. So there is a spread, which is called bid-ask spread, between the lowest ask and the highest bid. At the moment, market participants are submitting orders, limit orders, to the exchange, but it all happened that the lowest sell price is higher than the highest buy price, and as a result, nothing really happens. Let us do a short break, and I will get back to you in a few minutes. Okay, so getting back to our stuff, uh, can you tell me please, so at the moment, does it look like more or less clear? Maps, market participants submit orders for the
Yes.
Yes, I didn't discuss the situation when, for example, a buy order would be of a price higher than the lowest sell. We're going to discuss for them very, very briefly. But for the moment, you see, so basically there are maps, and the maps are accumulating orders, nothing else, all right? Maps accumulating orders.
I have a question.
Yes.
Do we somehow keep the prices of asks and bids? So we keep the map from price to the list of orders, but do we keep the list of prices which are in the map?
Good point. This depends on the implementation. And typically, for example, if you use, I don't know, Python, and you use a Python map, then there is a function keys which give you this list of prices. So somehow from the map you should be able to get it. My question for you, and although it is not our primary concern now, because we have already seen maps here, what are the maps in your favorite smart contracts programming language? So for example, if you use Viper, what are the maps in Viper? If you use Solidity, what are the maps in Solidity? How do they look like?
Well, as you know, in Solidity, we cannot obtain or actually we cannot get the list of all keys, because it is assumed that there is no actually if we take the value of unspecified of the key that does not exist, we will get just default value.
Okay, okay. So there are maps, but there is no easy function to get the keys. Okay. It may or may not be necessary to maintain the list of prices. In general, what you definitely do need, absolutely what you need to do, maybe not the maps of all prices, but you need to remember minimum ask price and maximum bid price here. So yes, these two entities you absolutely need to remember. We'll see in a second why. And obviously then this bid ask spread is precisely the difference. It is minimum ask price minus maximum bid price. And under all normal conditions, and that's very important, the bid ask spread is always positive. So it is not possible that in the order book the bid side collides with the ask side. In the order book, if it is a proper order book, minimum ask is always greater than the maximum bid. Well, that's very important to remember. If it happens like that, as we're discussing, then nothing really that much interesting occurs. So you see, both sides of the order book accumulate orders, but nothing really happens. There are orders, but there are no trades or no matches. Let us say that there is a concept, that's why it is a matching engine. Trade and match are same things. So for the moment, there are no trades because buyers refuse to increase the price. The maximum buying price is 0.009 and sellers refuse to decrease the price they ask for our coin. So the maximum remains 0.09, so nothing happens. And they both stand, you know, as in this very famous Russian proverb, as two rams on a bridge, and none of them agrees to give way to the other. Buyers insist on those prices, at most 0.009. Sellers insist on those prices, at least 0.01. So it is an order book, but there are no matches yet. So the question is, when matches occur, matches or trades, they occur when someone is tired of waiting. So for example, someone needs to buy our coin urgently. Why would they need to buy our coin urgently? Because the coin is a ticket, it is a proxy for a ticket to our gym, to our sports center, all right? A student would like to go to gym now, so they need a ticket right now. So what would they do? He was standing here at the price 0.009, or maybe not standing at all, just didn't even submit an order, but was looking just at the order book. And then he says, no, I need a coin now. In this case, what he would do, he would submit an aggressive order. What does it mean, submit an aggressive order? Either they would modify an existing order. Okay, before going into that, let me say that even before we are considering those aggressive orders. In this passive situation, when the orders are just staying in the order book, what can one do with the orders? Operations. There are basically only two possible operations. Submit an order or delete an order. Probably the order ID when you submit an order is not defined by the client. The order ID is to be defined by the system. So when submit an order, then new order ID is generated. By auto increment.
Can anyone see something?
Sorry, what do you say? Couldn't quite hear you. Excuse me, I couldn't quite hear your question. Okay, you are probably offline. So when you submit an order, new order ID is generated by the smart contract by auto incrementing a global counter. A much more complex situation occurs when you delete an order. You delete an order for many reasons. For example, you do not want to buy our token anymore. Then you placed an order in the order book and you delete it. Okay? Or you may delete an order simply to resubmit it. So you would like to change some parameters, for example, to change price, to change quantity, and then you delete the original order and you resubmit it. It is not possible to modify an order in place. That's a very standard situation actually in exchanges. So there is no in-place update. No in-place updates. And for that reason, you understand that if you delete an order and resubmit it, then it would be a new order with a new order ID and possibly new price, quantity. You may even change the site because what you do, you simply do a resubmission. It was an order to buy, now you want to sell, for example. Why not? It is a completely different one. Okay? Now, looking at this system of maps we have implemented so far, I am not going into the aggressive orders yet, just looking into our maps. Submitting an order is relatively easy. So you already understand how it could be programmed, for example, in Solidity. You submit an order. Well, for example, you submit, can you tell me please, so what happens when you submit a buy order?
The list with the price, with your price, is updated and your order is added to it.
One second. So first of all, suppose that it is a limit order, so it has a price. Okay. By the way, let's just do an algorithm. The algorithm would be like that. So, for example, submitting a buy limit order. It's not that simple. First thing you need to do is to check if order price, if it is a limit order, there is a price. Order price is less than the minimum ask price. It may be greater than the current maximum bid, but what is important is to check that it is less than the minimum ask price. If yes, then the order really comes to the order book. But if no, this means that the order is aggressive. And we'll discuss this. Order is aggressive. That's precisely what happens if someone is tired of waiting and they want to buy our coin immediately. Then they submit an order. Possibly they had already an order being somewhere in the bids. They delete that one and they submit a new order, now with a price starting from 0.01. So the price being greater than or equal to the minimum ask price. So what happens with aggressive orders? We'll see shortly. For the moment, suppose that we are in the yes branch. So the order comes to the order book. Then here, get map map entry for the order price. There may be this entry already in existence, maybe not. So if exists, then you modify the map. So now let's say bids map with the key being order price is modified. Now it contains previous entries and new order at the end. So orders, if correspond to the same price, they come into the first, they are arranged in the order of coming, latest at the end. If the map entry for this order price does not exist, then we install a singleton element for the moment. Would be just a single element list with a new order. Before that, before you check the price, you validate the order fields. For example, if you maintain a non-trivial price step, then order price must be proportional to a whole number of price steps. So validate, check whether it crosses the bid-ask spread. Order is aggressive, it means that the order crosses the bid-ask spread. If yes, if it does not cross the bid-ask spread, so it is still less than, strictly less than the minimum ask price, then we install into the order book. Otherwise, we need to handle an aggressive order. How to handle an aggressive order, we'll see shortly. But may I ask you, okay, that's fine. We understand this. But may I ask you, okay, we understand how to submit an order, how to delete an order. When you delete an order, then the delete request comes by order ID. For example. And actually, when an order is installed in the order book, the client should be notified somehow. We need to think how. Notify the client of the order ID. How can we do it in a blockchain environment, and whether we need to do it, we need to think about. But okay. Now suppose that the client wants to delete an order. How would they delete an order by order ID? Looking at this, you can see that it would be problematic, wouldn't it be? In order to delete an order, again, sorry for tautology, you need to find it somewhere in the order book. But how to find it? It could be on either side and within any price level, and even at that price level, it could be the first, second, and so on. So to delete it, does it mean that we have to traverse the whole structure of the order book? That would be hugely suboptimal, wouldn't it be? Hugely suboptimal.
Maybe we can just keep another map.
Yes, we keep another map, which is index of orders. So in this case, we need index of orders. You are absolutely right. And this is a map from order ID to, you know what, maybe even to the order itself, because then full details of the order are known. And in that case, here, we do not really need for bids and tasks to have a full map with full orders. What we need to do is here only store the order ID, basically. Instead of having a full order, I put it in a red. We only need order ID here. So the order book is a map from prices to lists of order IDs. And separately, we have a map from order IDs to full details related to that order. I think that's a quite good arrangement. So we still need to discuss aggressive orders. Actually, that is only half of the story, what we covered now. We covered the order book composition. We already know that aggressive orders will result in trades matches. How? Also called matches. How? This is to be discussed next time. But unfortunately, our time is over now. So next time on Thursday, we'll first of all discuss how matches occur, what kind of transactions would occur in the Ethereum blockchain as a result, and what kind of data structures and smart contract layout we are going to implement in order to have this functionality done. So until Thursday. Are there any questions, any more questions for today? If not, let's meet on Thursday. Thank you.
Goodbye.
Bye, everyone.